A circuit failure can be expensive and sometimes dangerous. Many machines, vehicles, medical devices, and power systems rely on small electrical parts to work correctly. If one important part fails, the whole system may stop working. One of those parts is called the capacitor. A capacitor stores electrical energy and helps control voltage on the circuit. Over time, these capacitors slowly wear down, and the problem is that this damage may not be obvious until the capacitor is close to failing. So instead of waiting for failure, it will be useful to predict how much life the capacitor has left. This is called its remaining useful life, or RUL. My project explores whether a deep learning model can use voltage data to predict the remaining useful life of a capacitor in an RC circuit. Now, it's important to begin with some background info. First of all, an RC circuit is simply a circuit containing a resistor and a capacitor. And within these capacitors of the RC circuit lies a dielectric material placed inside the capacitor to increase capacitance. As the circuit runs over time and continues filling up the capacitor, these dielectric materials break down due to stress, whether it be electrical, thermal, or from other sources, spiking the resistance and lowering the capacitance. Now, another concept, voltage decay, is the rate at which a capacitor's rate of voltage flow decreases over time. What's important to note here is that the voltage decay rate is dictated by the degradation of the circuit and time constant, and therefore the dielectric degradation within the capacitor. This is what brings us to our theory. If the voltage decay of a circuit is determined by the degradation of the capacitor, then the change in rate of voltage decay, or the change in rate of the change of rate of voltage, should be able to be reverse engineered as an indicator to predict the remaining useful life of the circuit, aka the point at which a capacitor drops by 20% of its capacitance. That is what brought me to my goal. Since there is no direct equation to using just voltage to calculate the changes in capacitance, that we can build a neural network that can train itself off of capacitance and voltage data, that when it's fed a single time period of voltage, that it'll be able to predict the RUL for future circuits. For my dataset, I used the NASA PCOE Capacitor Electrical Stress Dataset to simulate a situation with real RC circuits in industrial settings. The model's input was a snapshot of the voltage decay curve, and the output was a value from 1 to 0, based on what percent of the capacitor's useful life is remaining. 1 meaning the capacitor is new, and 0 meaning that it has reached failure, or 20% in decrease. The model tries to learn how changes in the shape and slope of the voltage curve relate to the age of the capacitor. The model uses one-dimensional convolutional layers, and these layers scan through the voltage signal and look for patterns. The model then reduces the data, keeps the most important features, and produces one final remaining life prediction. I trained the model on 6 capacitors and tested it on a 7th capacitor that I had never seen before. The graph compares the real remaining life with the model's prediction. The prediction is somewhat noisy, but it follows the overall downward trend from a healthy capacitor to failure. For example, at one point, the model predicts around 46% remaining life, while the real value was around 44%. Near the end, the model predicted a value close to 0. Overall, the model showed that voltage decay can be used to estimate capacitor health. This could be useful for predictive maintenance by helping sudden failures be prevented, reducing repair costs and improving safety. With more training data and smoother predictions, the model can be more accurate and reliable. Thank you.